This is my attempt to build a switching capacitor audio filter. I started off by modeling it on a project by the New England QRP group, their Nescaf filter. So I downloaded their instructions. It's a nice project. Board is about $30. Turned out that I had just about all the components, so I thought I might try doing it without the board, although I certainly appreciate supporting the group and might get some other things from them in the future. So I started off on a proto board, and I'll walk you through the layout of the board. It runs off 12 volts. My 12-volt battery is hidden up there. Through a 9-volt regulator. There are 3 chips on the board, a 555 timer. The frequency output of that sets the center frequency on an MF10 Nescaf integrated circuit. And then there's an LM386 audio amplifier. There are 3 pots on the board. A double ganged pot sets the center frequency. It sets the bandwidth. And the ganging allows you to adjust both the high and the low at the same time, and proportionally. There's a volume control, which is not actually broken out onto a separate pot in the original design. You set a unity gain essentially on the board. I thought it'd be nice to be able to control the audio, so I put it on its own pot. That will be panel mounted. And then the center frequency, there's actually 2 pots. There's a little one, a trimmer on the board, which allows you to set the panel mounted one so that the center is whatever your desired center frequency is. So for Morse code, I like 800 Hertz. So I set the trimmer so that the center of this pot is 800 Hertz. And there's a power LED just to make sure that everything is on. And for the time being, I've taken the input and the output and just put it into this strip, which breaks it out into 3.5 millimeter plugs just for convenience. So I have one computer set up. That's going to be the audio source, and the other computer over here is running MixW, because I can use that as a audio spectrum display. It's waterfall. So to start off with, let's use no signal going into it, and I'll turn audio gain all the way up. One reason I prototyped it was just to figure out which way the pots had to be wired in order to give the expected result when I turned them. So nothing going in. This is just the internal noise of the board, which of course is higher because it's broken out as a proto board. Let's go to maximally narrow bandwidth, and what does that give us on our display? So this is just the internal noise from the circuit, which is suboptimal because of the construction. So I'm moving the center frequency around, go up higher, and you can hear it. I have a speaker also wide in. Not sure why we're getting howling. I don't think that's part of the design. Anyhow, moving around somewhat where the noise is, but there's no signal coming through, so it's good that we're not getting a big signal out, just a hiss from the 386. So let's play white noise. So there you go, there's more noise coming through, noise energy on the display. And most of it is in a fairly narrow band towards the bottom. So I'm going to sweep from low to high. With the center frequency. So that sort of makes sense. We're getting some isolation of those frequencies, and it's a fairly narrow band. Alright. So actually, let's bring it down a little bit in frequency. And widen the bandwidth. And move the center frequency around, low, and high. middle and turn the gain down. Alright, so grossly that works. Now let's play a PSK session that I captured maybe a year ago. We'll turn the gain down. Now we're maximal wide. I'm going to go to minimal width on bandwidth. And we'll go towards the lower end. We can isolate one of these signals. And we're able to pick that up. Now if I widen the bandwidth, there's less emphasis on that lower frequency signal. And similarly, if I go up in frequency and narrow again, then we're seeing more of the waterfall at the higher end of the spectrum. The numbers are not correct. This isn't actually hooked to a radio at this point. It's just an audio file. And again, it's decoding it pretty well. So that's it. I think the circuit basically works. Just a matter now of putting it onto some vector board and maybe shortening lead lengths and that sort of thing. I think that'll help improve the static and the noise that we're picking up from other sources. That's it.